Okay guys, I welcome you all to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now let's solve this problem which says that during operation the jackhammer strikes the concrete surface with a force which is indicated in the graph. To achieve this, the 2 kg spike S, we have this 2 kg spike S. It is fired into the surface at 90 meter per second. So the velocity of the spike into the surface is downward, and that velocity is 90 meter per second. Determine the speed of the spike just after rebounding. So when it will strike the surface, so there will be the velocity in the opposite direction. There will be a force on this spike and we will have the velocity in the opposite direction, and we are required to find that velocity. So let's say that after the rebound the velocity is, let's say, v2, and the initial velocity is, let's say, v1. Now we have to apply the law of conservation of momentum, which says that the initial momentum, that is mv1 plus the impulse due to the external forces, this is equal to mv2. So initial velocity is 90, so we have to write that the mass of the spike is 2 kg, so we will write 2 into v1, which is 90, and the external force is from the surface, so the external force on the spike will be acting in the upward direction. So let's say this is that force F, which is given here in the shape of this graph. So this impulse can be determined by finding the area under this graph, right? Since, as we can see, that the area of this graph will be F times T. So this is F times T. So we will write this plus area under the f of t graph, and this is equal to m. Again, the mass is 2 and we have to find v2. Now the area is, we can write that the area under the graph is 1 divided by 2 base. So base is 0.4 minus 0, 0.4 minus 0 into height. So height is 1500 minus 0, so this is 1500 minus 0. So this is 1 divided by 2, 0.4 into 1500. So we can write this as 0.4 divided by 2. Let me find this. This is 1 divided by 2 is 0.5 multiplied by 0.4. And if we look into the graph, so the time is in millisecond. Remember, this is in millisecond and this is in kilonewton. So we have to consider these milliseconds and this kilonewton. So first of all, if I write that this will be 0.4 milliseconds, so we have to write, let me write it like this. This is in milliseconds. This is 10 raised to the power minus 3, and this is in kilonewton. So this is 10 raised to the power 3. So these will cancel out. So we will be left with this same equation. So this is 1 divided by 2 into 0.4 into 1500. This gives us 300. And the units will be 300 Newton second. So this is the impulse due to the external force. So we have to write that this is 2 into 90. This is, and if we are applying this law of conservation of momentum in the vertical direction. So let's say this is my positive direction, positive vertical direction. So as we can see that the initial velocity is acting in the downward direction, so that is in the negative direction. So we have to write minus sign here. So this is minus 180 plus the impulse, the area under the curve, which is 300. This is 300 and this is equal to 2 into V2. So now 300 minus 180, so this is 120. This gives us 120. 120 equals to 2 times V2, and we can say that V2 is 120 divided by 2, which is 60 meter per second. So this is the rebound velocity of the spike when it just hits the surface. So this is that velocity which was required. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Dynamics.